Detectors of flue gas composition. Excess air optimization. Part 4. As shown in the attached figure, excess air can be correlated to oxygen, carbon monoxide, or carbon dioxide, or combustibles present in the flue gas. Combustibles are usually detected either as unburned hydrocarbons or in the form of opacity. These measurements are not well suited as the basis for optimization because the goal is not to maintain some optimum concentration but to eliminate combustibles from the flue gas. Therefore, such measurements are usually applied as limit overrides. The relationship between excess oxygen and carbon monoxide or carbon dioxide in the flue gas of a boiler operated at a constant load is a function of the type of fuel burned. The same figure as in the previous slide but little bigger in size for your quick reference. Request: it is hoped that this session is going to be useful to you. Please press like button. Please subscribe this channel. बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा। The measurement of carbon dioxide is not a good basis for optimization either because, as shown in the attached figure, its relationship to excess oxygen is very much a function of the type of fuel burned. The CO2 concentration of the flue gas also varies slightly with the carbon dioxide content of the ambient air. It can also be noted from the attached figure that carbon dioxide is not a very sensitive measurement. Its rate of change is rather small at the point of optimum excess air. In fact, the carbon dioxide curve is at its maximum point when the combustion process is optimized. The probe type oxygen analyzer should be installed close to the combustion zone but at a point where the temperature is below the limit for the zirconium oxide detector. The same diagram as in the previous slide but little bigger in size for your quick reference. Excess oxygen as the basis of boiler optimization is also a relatively insensitive measurement, but it is popular. It uses zirconium oxide probes. In order to minimize duct leakage effects, the probe should be installed close to the combustion zone, but still at a point where the gas temperature is below that of the electrically heated zirconium oxide detector. The flow should be turbulent at the sensor location, if possible, to ensure that the sample will be well mixed and representative of flue gas composition. The output signal of these zirconium oxide probes is logarithmic. The correct location of the probe will reduce but will not eliminate the bias error caused by air infiltration. Ambient tramp air enters the exhaust ductwork not only through leakage but also to cool unused burners and registers. The oxygen probe cannot distinguish the oxygen that entered through leakage from excess oxygen left over after combustion. Another limitation of the zirconium oxide fuel cell sensor is that it measures net oxygen. In other words, if there are combustibles in the flue gas, they will be oxidized on the hot surface of the probe and the instrument will register only that oxygen that remains after this reaction. This error is not substantial when the total excess oxygen is around 5%, but in optimized boilers in which excess oxygen is only 1%, this difference between total and net oxygen can cause a significant error. As infiltration tends to cause an error toward the high side, while the fuel cell effect results in a low reading, the amount of uncertainty is too high to rely on oxygen sensors alone when maximum efficiency is desired. Other limitations of optimization based on excess oxygen include the fact that local problems at the burners can result in incomplete combustion even when the excess oxygen in the flue gas is normal. Another limitation is the precision and accuracy of such excess oxygen curves as shown in the attached figure. The precision is a function not only of the resolution at which the curve was prepared, but also of changes in fuel composition and boiler conditions. Request: it is hoped that this session was useful to you. Please press like button. Please subscribe this channel. बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा.